Osteoclast. Osteoclast is a large multinucleated cell. It has about 15 to 20 nuclei. Its origin may come from fusion of the macrophages / monocytes. As many as 50 of the cells fuse together to make a giant cell. Osteoclast absorbs the bone. This function is regulated by the osteoblast. Osteoclast lifespan is few days. One osteoclast can create a lot of damage. It will take 3 months to replace the bone removed in few days by the osteoclast. It may take 100 to 150 osteoblasts to replace the bone removed by one osteoclast. It has a lot of mitochondria. It's actually a machine. It is found against the bone surface in a hollow depression called the house-shaped lacunae. That's where bone resorption occurs. The house-shaped lacunae, it is the site of bone resorption where the ruffled border meets the bone surface. When they absorb the bone, they develop ruffled border and sealing zone. It secretes two enzymes. Cathepsin K is an enzyme that is released by the osteoclast at the ruffled border. It absorbs the osteoid. Mutation of the gene will lead to a problem of bone called pycnodysostosis. Another enzyme is tartrate-resistant acid phosphatase, which dissolves the hydroxyapatite crystals. So how this resorption occurs? The osteoclast attaches to the bone by two proteins, anchoring proteins. The integrin is on the osteoclast and the vitronectin is on the bone. The integrin and the vitronectin lock to each other, creating a sealing zone. And then the osteoclasts create an acidic environment by producing hydrogen atom through the carbonic anhydrase, which demineralize the bone and exposes the organic matrix. This occurs by sealing the space below the osteoclast and lowering the pH and increase solubility of the hydroxyapatite crystals. Then the matrix is also degraded by cathepsin B. It is another enzyme that works on the organic material. It is a lysosomal enzyme. Deficiency of carbonic anhydrase leads to osteopetrosis. So what is the clear zone? The osteoclast binds to the bone surface through cell attachment utilizing anchoring proteins. The clear zone is a cytoplasmic area presenting the adhering plasma membrane or the sealing membrane which surrounds the ruffled border and seals the absorbing compartment. Osteoclast has two centers on its surface, the calcitonin receptor, which inhibit the osteoclast, and the rank receptor. The rank ligand binds to the rank at the surface of the osteoclast and stimulates the osteoclast. Where do you get the rank ligand from? You can get it from the osteoblast and from the tumor cells. That rank ligand, which binds to the receptor on the osteoclast, will stimulate the differentiation and activation of the osteoclast and increase bone resorption. The rank ligand function is inhibited by the OPG, osteoprotein. So what is really against the osteoclast? The OPG, which protects us from excessive bone loss by blocking the rank L, the balance between them is important. The calcitonin and IL-10 and drug called denosumab. Denosumab is a monoclonal antibody to rank ligand. It's like an OPG. OPG is the decoy receptor prevent rank L signaling. Biphosphonate would prevent osteoclast from forming the ruffled border and producing acid phosphatase. It may also cause death of the osteoclast. Rank L will stimulate the osteoclast. Remember, the osteoclast activity is controlled by the osteoblast, which is controlled by the parathyroid hormone. Interleukin-1 will stimulate the osteoclast. You find it at the membrane of loose total joints. The macrophage colony stimulating factor M-CSF is a cofactor required for the action of the osteoclast. Thank you very much. I hope that was helpful to you.